Welcome back. In this video, we are going to study or review some of the properties of real numbers. So more vocabulary, some things you've seen before, some things may be new. First property we're going to look at is closure. Mostly we're going to work with the real number system. The real number system is a closed system. Essentially, if you impose a mathematical operation or operations on a real number or the set of real numbers, the result will also be a real number. So if you work with real numbers, you put real numbers in, you are going to get real numbers back out. So, and that works with any set beyond just real numbers. You might have a set of different numbers, and the question is, might be, would that set be closed with addition or subtraction or multiplication or division? So if I had a set of numbers like 0, 1, 2, and 3, and we'll just leave it at that, is that closed with respect to multiplication? So multiplication, closed. Well, let's see. What if I multiplied 2 times 3? Well, I get 6. So with respect to multiplication, this particular set is not closed. Maybe with addition it is. Well, not even that. With addition it's not closed either, because 3 plus 2 is 5. So you get the idea. This particular set is not closed with respect to multiplication or division. Maybe subtraction, maybe division, but I'll leave that to you to figure out. The next property is the commutative property. So the commutative property, again, this is vocabulary, so I want you to think about what it means to commute. What does it mean to commute to school or to work? It means to go back and forth. Okay? So the commutative property says we can switch things around or go back and forth and still get the same result out. So let's say we had x plus y plus z. Well, that is going to be the equivalent of y plus x plus z. So in our example here, the y and the x, they commuted. They changed spots, but these are still equivalent. And multiplication is also commutative. If we had x times y times z, that's the equivalent of y times x times z. Once again, we commuted the y and the x. Now we could have commuted like the y and the z, and that would still be the same, right? This would also equal x times z times y. The associative property. The associative property, now I want you to think grouping. You know, who are your associates? Who do you hang out with? Associative property is grouping. So a little bit different than the commutative property. And we have an associative property with respect to addition and multiplication. So we'll work with our x, y, and z again. But here we're going to group x plus y, that quantity, plus z, is the same as x plus y plus z. Here, we had, on the left, we have x plus y is grouped and y plus z is grouped. While with addition and multiplication, the groups don't really matter. So x plus y, x times y times z is equal to x times y times z, where we group the y and the z. Okay? So it doesn't matter with the associative property with respect to multiplication. So we group the x and y on the left and the y and z on the right. Notice I kept the order the same. X, y, z is the same from left to right. In the distributive property, we want to apply a number or a variable or something to an entire quantity. We've used and seen the distributive property quite a bit in our math careers. So we have x times, say, y plus z minus m. Well, if I apply the distributive property, I'm going to impose the x on everything. I'm going to multiply x times every single one of those terms. So we get x times y plus x times z minus x times m. The inverse for addition, or the additive inverse, we've already seen that so far this school year. That says A plus its opposite will equal 0. So any number and its additive inverse, or and its opposite, is equal to 0. Right? 7 plus a negative 7 equals 0. The inverse for multiplication, a little bit different. Okay? We've seen the multiplicative inverse. That is really the reciprocal. So the inverse for multiplication, that says some number multiplied by its reciprocal will always give us 1. So 3/5 times 5/3 equals 1. That's the multiplicative inverse. The identity for addition. The identity for the addition, the identity is essentially, when we're adding, it's saying, what do I have to add? What do I add to a number in order to get the same number back? So to get the same number back. Well, if I add 0 to a number, I'm going to get my same number back. Okay? So any number plus 0 will equal that same number. X plus 0 is equal to x. So the identity for addition is 0 when I'm adding. So the identity for multiplication is the same thing, but instead of add, the identity for multiplication is, what do I have to multiply a number by to get that same number back? And I'll leave that one to you to see if you can figure out what the identity for multiplication is. What do I have to multiply a number by to get that same number back? And we've done that quite a bit this school year already. Properties of equality. Well, the reflexive property says that every number, every single number, is a reflection of itself, or any equation is a reflection of itself. A plus B equals A plus B. Okay? Now if I did here, I did A plus B equals B plus A. This one is the commutative property. That's not reflexive. This is reflexive. A plus B equals A plus B. Nothing's changed. The symmetric property, this one's a little bit more involved. It says, and this is of equality, if A equals B, then B equals A. And one thing about symmetric is we'll always have this if-then business in there. And then the transitive property, well, you saw this in grade school, the transitive property of equality. It's a linking, okay? This is a linking. It's kind of a chain of reasoning. You'll use this quite a bit in geometry. And it says, if A equals B and B equals C, so we've got this link with B, then A must equal C. So A equals B equals C. Okay? Our link here is with the B, and that's the transitive property. If, and, then is transitive. So there's a good summary of the properties that you will be seeing in algebra this year. We'll have some problems to work on and some worksheets. So you'll have to practice those. It takes a while to get familiar and identify those, but we will work on that when I see you in class.